We're good? Awesome. Thanks everyone for joining us today. And this presentation is going to be conducted by Hulu. My name is Ilan Sahayek. I'm the Principal Product Manager for Amazon Pinpoint, and I work closely with the Hulu team. And we wanted to share their experience in using Amazon Pinpoint. So without further ado, I'm going to introduce the Hulu team. Great.
Thank you, Ian. So, yeah, I'm Ian Wang. I'm the Principal Engineering Manager for DVR platform and also messaging platform at Hulu. With me is my partner, Minghui Liu, the Principal Software Engineer in the messaging platform team. So today, we're excited to be here to talk about our experience of building the real-time live sports notification platform for Hulu's live TV by using Amazon Pinpoint. So here's our agenda. I will give a very quick introduction about Hulu, and then I will talk about our goals when we built our notification platform. And Minghui will use most of the time to talk about our solution with Amazon Pinpoint, why we chose Amazon Pinpoint, and how do we use it. And we will share some of our key learnings and future plans. So please do me a favor. Please raise your hand if you have ever used Hulu. Thank you. Please raise your hand if you ever use Hulu Live TV. Not very, less than the first. That's obvious. So Hulu is a premium streaming service for VOD and live TV content. We also create a lot of great Hulu originals. One of the great examples is Handmaid's Tale. We won the Best Drama from the 2017 Emmys. We have more than 20 million subscribers, and we have more than 1 million live TV subscribers. So before we talk about solution, I want to talk about our goals when we build this platform. So Hulu is available across different types of platforms, including web, mobile, tablets, and also a lot of different living room devices. But our topic today, we will focus on the push notification for the Android and iOS clients. The user scenario we want to talk about here is to send the push notification to the Hulu end users when the live game starts on the live channels. So you can see the screenshot on the right side. This is an example of the notification we send to our user when the live game starts on Hulu's live channels. So once you click the notification, we will open the Hulu application and bring the user to the live channel where the game is airing. So it sounds very simple, right? But actually, it's much more complex when we build our notification platform with a list of aggressive goals I'm going to talk about right now. So the first goal we want to achieve is to send the notification to the right audience. Obviously, we can only send notification to the user if they have already obtained the notification permission. But more importantly, we should only send notification to the user who has the interest on Hulu's specific content. So on the right side, this is a screenshot of our Hulu's iPhone application, the team page. So at Hulu, we use My Stuff to manage users' interest about the specific content. So here, the user has shown the interest on the NFL team, which is Los Angeles Chargers. So based on that, we know the user has interest on the games from that team. And also, we should only send notification to the user who is able to watch the specific game, which actually is more challenging in the live TV product because the different local live TV channels is only available for the specific group of people in the specific location. And Minghui will talk about the challenges we have to resolve this kind of problem. So another goal we have is the deduplication. So it's very common the same knife game is available across multiple knife channels we have at Hulu. But we don't want to send multiple notifications to the same user about the same thing. So our goal is to only send one notification, even though it's available on multiple knife channels. And also, we don't want to send notification to the user if it's a rerun. And if they have ever watched it, we don't want to send notification either. And the third goal we have is to handle the schedule updates. So it's very common the program schedule may be changed in the live TV product. So here I have an example of the 3 games, 1, 2, 3 on the same channel. And we get the information, metadata, from our partners to let us know where the program is going to start and where the program is going to finish. So we call it out-of-band metadata. We also get the in-stream, the metadata from the partners from the stream when the program 1 is airing. It's very common the program may be extended at the last minute, which means the start time and end time of the program 2 and 3 has to be changed. So in this case, we want to send notification to the users who have the interest of the program 2 and 3 at the right time based on the up-to-date schedule information. So here, that's how we update the schedule, the start time, end time for the programs in the same channel. So last but not least, goal we want to achieve is the SLA. The first part of the SLA is the scalability. So for our live notification campaign, basically we have 3 steps. We need to build the right audience, and then when program starts, we schedule the campaign by using Amazon Pinpoint, and then the notification will be delivered to the end users. So even though when we build our platform for our live sports notification, but we also want to reuse the same platform for our SVOD content. So the audience size can be as large as 20 million for the SVOD subscriber use cases. And also it's very common we may have multiple campaigns running at the same time, which means even larger scalability we need to handle in this case. Another part of the SLA is the latency. So we want to send a notification to the end users within 1 minute from the time when the program starts and the time when user receives the notification, which is actually a very aggressive goal we have defined. So with the list of goals we have defined, I'm going to hand over to Minghui to talk about our solutions with Amazon Pinpoint. Thank you.
Thanks, everyone. My name is Minghui, and I will walk you through our solution with Amazon Pinpoint. So I will start from our high-level architecture. So our system basically has 3 components. One is messaging pipeline, which answers which game we should send a notification, when we should send notification, and who we should send notification. The second component is our messaging platform, which is a generalized messaging platform in which we define a list of real-time processing, for example, do the duplication, filtering, ranking, and quota control. And the third component is our messaging delivery component, which is responsible to integrate with the third-party delivery service to do the last-mile notification delivery. We choose the Amazon Pinpoint as our third-party delivery service. Actually, we investigate a few other alternatives. Why we choose the Amazon Pinpoint? The most important reason is it can provide our expected SLA, and we have the expected SLA in a few areas. So the first one is we could create segments and campaigns dynamically from our backends, and the second one is we could import large segments, and we mentioned our segments could be as large as 20 million users. The third goal, SLA we have is we need to make sure our notification could be delivered to our end user in a very short time window. So we want our user receive notification exactly right after the game start. So there are a few other reasons why we choose the Amazon Pinpoint. For example, we can create the campaign and segments from our backend through their API or SDK. And Amazon Pinpoint doesn't require us to integrate their mobile API or SDK. The reason is Hulu nowadays, the mobile app integrated more than 20 third-party SDK. And our mobile team believe this introduced some quality issues and risks into our mobile app. So they like not integrate more third-party APIs or SDK to make sure our mobile app quality is high to provide the best user experience. So the Amazon Pinpoint provides the flexibility. We can reduce our user notification permission from backends. We can create all those segments campaigns from backends. So Hulu has the full flexibility about how we can implement our notification system. And for sure, without integrating with the Amazon mobile SDK, we miss some Pinpoint features. For example, the Pinpoint campaign reporting and analytics. This is a typical, benefit and risk balance. Okay. So then I will dive into each of our components. The first component is our messaging pipeline. We need to know which sports game we want to send notification and when we want to send. Now Hulu has more than 1,000 live channels. Here is an example of the NFL game happened this month. It's between the Dallas Cowboys vs. Philadelphia Eagles. Hulu had more than 150 live channels aired this same game. And most of them are local affiliates. Local affiliates means their live content is only available in a dedicated area. We call it a distribution area. So the more challenging part is those local affiliates distribution area could have overlap. That means the same user could be able to watch multi-live channels airing the same game. And on the right side, you can see that is a map of the distribution area of local affiliates from NBC network. That is just the NBC network. You can see how complicated it could be. And Hulu actually have more than 100 networks right now. So when we talk about the live game notification, the most important is the time, right? So the live content program schedule is very challenging because even for the same game, different live channels could have different schedule. There are a lot of reasons contribute to this. Here I list the two most common one. The first one is some live channels have pre-games and some others don't. And some live channels have different commercials from the others. If you are sports fans, I think you are very familiar about the game extension. A lot of games got extended at the last few minutes. And there are a lot of reasons. Could be, they run into a tie, or there is weather, or there is local breaking news. This will all change the game schedule at the last few minutes. We cannot know the exactly schedule at the last minute of the previous game. So Hulu get typically two kinds of schedule information. The first one, we call it afterbound. That's the schedule we got before the game start. Typically, we get the estimated schedule information 40 days before the game start, but some content we only get 1 day before the game start. Another type of schedule information is the inbound schedule information. It's the schedule information we get inside of the video stream. So it will tell us, okay, the game really start. So Hulu get those schedule information from our content partner like NBC, ESPN, and also Hulu partners with third-party metadata provider like Gracenode. Our Hulu metadata team need to unify all of those schedule information and model them into a unified content data model. They need to match. They need to make sure, okay, the schedule information from ESPN about the game and the Gracenode about the same game, they are talking about the same game. We need to match them together, and then our metadata team will publish the unified schedule information to the downstream. So even Hulu metadata team tries best to unify those schedule information, but we live in a world, the live TV schedule is very complicated. There are always cases the schedule information is not accurate, they cannot match this kind of issue. And we need to make sure to build the robust system to no matter the schedule information is have some shift or incorrect or user click notification maybe several hours after the game start, we can't deliver the best user experience. So the Hulu metadata team publish the real-time schedule change events. Our messaging team listen to those changes and store them into a ready sorted site. With the ready sorted site, you can easily to fetch what's the coming game events. With that, 30 minutes before the game start, it is the estimated schedule, right? We can start to pull the events, process the event, enhance the metadata, and get the right audience. And I will talk about how we build the audience in seconds. And then after get the audience, we can create the pinpoint segments. We choose the 30 minutes before the estimated schedule is. We don't want to create the schedule, the segments too earlier, because there are a lot of things could change. Users' interest could change, their context could change, our distribution area list could change. So we want to capture those changes as much as we can. But we also don't want to build the segment too late, because sometimes the previous game may end earlier. We may lose the chance to send the notification exactly at the game start. So we choose the 30 minutes to balance those two things. And when we get the real game starter events in the stream, we will trigger the process to create an immediate campaign on Pinpoint to deliver the notification. That's one feature Pinpoint provide. Okay. The next component I'm going to talk about is our audience building platform, which answers who we should send notification. As a recap, we should send the notification to the right audience. Relevance is another important properties of notification. And we should only send notifications who have opted-in Hulu notification, show interest on the sports game, typically the team of the game. and we should make sure the user is able to watch the sports game. And we just talk about how live TV introduce a challenge in this area, and the user could watch multi-channels, and this multi-channel could have different schedule, and that is the challenge we need to solve. So we build our audience platform, which has functionality, giving a live sports game, find all the users who have shown interest on the teams of this game and who can watch the game. This audience building service need to make sure the audience targeting is accurate, and it can handle the high throughput, the low latency, and have a high uptime. So the challenges of this audience platform service, the first one is the query pattern. And you can imagine most of the channels, they will start a new sports game exactly every hour or half hour. So a lot of those channels will start a new game at the same time. And all other times have much less game start events. So the request is very spiky. And the second challenge is there are a lot of games, only available in a very small area. They only may target thousands of users. But there big games could target millions of users, like Super Bowl. We need to make sure our audience targeting platform can handle the spiky requests and the high throughput. The second challenge is updates, and we mentioned the users, their interests and contexts are always changing. They could favorite new teams, remove teams from their favorite, change their subscription type, change their location. We need to make sure this platform always serves the update data. So the most straightforward and simple solution we can think about this is, let's just scan our whole user base to check their subscription, their interest, and their location. And obviously, it is not performant. We build our solution on top of Apache Lucene. Apache Lucene is a performant, full-featured text search engine. We treat our users as a document and the users' attributes as a word of the document. So we build the inverted index of those words, so we can search our users on top of this inverted index. So we choose the Apache Lucene is because our search team built a very mature infrastructure about the Apache Lucene cluster, so we can easily to adopt our solution on it. But with the trend moving cloud, and we also considering how we can leverage the cloud products like Amazon Elasticsearch. Actually, they're almost similar functionality. I will talk about this later. And our basic workflow is the indexer load all user base with their attributes, build the index file, and our search engine could load the index file, listen to the changes, and keep the index file up to date, and then it can serve the search request. So how we build the inverted index? Here is an example of 3 users. Each of them have the attributes like interest, subscription type, and location. We treat each of the users' attributes as a word, so we can build the inverted index for this word. The list of the user is those users who have those interests. So with this inverted index, how we will search. Here is an example of the NFL game, the Philadelphia Eagles at the Dallas Cowboys. And so it has two teams, right? The Dallas Cowboys and the Philadelphia Eagles. And the game can only be watched by our live subscriber and who live in the Dallas area. So the request will be find all the users who have shown interest on either or both teams and who also lived in this area. So the inverted index of the Eagles team, it has Alex and James. And for the availability index, we have the only have the James. So our search engine will find the result of each index and join them together to find the real the final user list. So this is a simple example of our search flow. So from the example, you can see our flow is given a live game, find the game's teams, the subscription, and the location of this game, and then our search engine will find the index type of, find the users of each index type, and then our search engine join them together to return the user list. Why this solution is efficient? The most important is the index building process is an offline process. So no matter how heavy this offline process is, it won't affect our online query. So the second part is the index itself and the users inside of the index I ordered. So the search of the index and user are very performant. When the search engine gets the users list from each index, it can join them very quickly. It's because the user are stored by skip list inside of the index. So it is very efficient to join two skip list or multi-skip list together. The real-time updates. So whenever we need to a cold start of our index platform, our full index will load the whole user base and get all the attributes of this user, build the full index file. So our search engine can load the full index file. And at the same time, we have an incremental indexer which listen to the user's attributes change, their interest change, subscription, they upgrade or downgrade their Hulu package or change their location. We capture all those changes and build the index change and publish to a queue. And each of our search engine can listen to the changes and apply those changes to its index. So the search engine, the search engines are always serve the up-to-date to the updated data. Scalability. So nowadays, for those millions of users, our search engine still use very limited resource. The index file is only just 1 GB, and the heap memory the search engine uses is less than 4 GB. So there we have a much bigger room to scale our platform to support more scenarios, more throughput. We also mentioned if we move to cloud to leverage cloud products like Elastic Cluster, then we have even big room to scale our platform. So it is it is very resource efficient. Okay. The next component is about our messaging platform. Now we know which game we should send, when we should send, and who should send. We get all of those things. we defined a list of real-time delivery pipeline components to handle the real-time processing, like filtering. So we need to make sure we won't deliver duplicate notification to our user. Our dynamic live game start notification will send notification to our user. And sometimes our editorial team also send ad hoc campaigns for very popular games like Super Bowl, Olympics. We need to make sure, even with all different categories, our user won't receive notification. So we need to real-time process of this. The second is about watch history processing. So we have the live content. Those live content could rerun, and we have VOD content. We have various of content type. So we need to make sure we won't send notifications if user ever watched the content before. But it is a very rare case for live sports scenarios. We are working on the ranking components of our messaging platform to make sure our user always receive the most relevant games they have shown interest. The quota control. Amazon Pinpoint provides the basic quota control. For example, you can configure your whole Amazon Pinpoint application or a single campaign. Each user won't receive more than 5 notifications per day. But that configuration is just application level or campaign level. In Hulu, our messaging platform support various of categories of notification. For example, the user's account information, like password change, or their account run into risk, or this kind of thing. And we also support transactional notification, marketing notification, and also the dynamic live sports notification. Each of these category may need different rolling window, may need different quota. So we build our own quota control to support those scenarios. The next component is messaging address. So we mentioned we don't integrate the Amazon Pinpoint mobile SDK. So we cannot register our users' notification permission from our Hulu mobile app. So our mobile app need to register the notification token back to our backend system. This component is to keep track all our users' notification permission and some context with for the device. For example, the device time zone, the device, the platform, the device type. So we can make sure we have the capability to deliver the notification for the specific set of device. For example, we launch a new iOS feature. We need to make sure this notification only delivered to iOS device. And for some of the notifications, we want to send to the users at 5 p.m. at their local time. So we need to know the time zone of those devices. So basically, the messaging address is keep track of our notification permission and the associated device context. Okay. The last component is about the message addressing, which is responsible for integrate with Amazon Pinpoint to deliver the notification. And actually, Amazon Pinpoint has delivered the notification through the platform service. Like on iOS, it's integrated with for Android, integrate FCM. For iOS, it integrates with the push notification service. The Amazon Pinpoint integration. So we store all our audience segment in Amazon S3. And then we create segments on Amazon Pinpoint, and then we import the segments from S3 files. So when the game starts, we create the immediate command deliver. It is a very straightforward and simple integration, right? But we still have a few advice here. The first one is load testing. Load testing a push system is kind of tricky and challenging. But luckily, both iOS and Android provide the silent notification mechanism. Basically, you can deliver a payload to your mobile app without displaying any message to your user. So with this feature, we can create a silent notification campaign and do an end-to-end load test to make sure both our system and Pinpoint can handle our load. So it is very helpful for us to detect the bottleneck of our system. The second is the large segment. Our campaigns segment could as large as 20 millions. Processing those segments in real time is challenging. And Pinpoint provides the feature you can import the segment from S3 folder instead of a single S3 file. So it gives the flexibility. We can parallelize our audience processing. For each of the partition, we process it and save it to S3 file, and then Pinpoint can load all those things from the S3 folder. And it significantly reduced our audience processing time. The third is error handling. Error handling is always the basic and important engineering practice. So you need to handle server-side error, network error, timeout, retry, all those things, right? And one tricky thing about this, about idempotency, we need to make sure we won't deliver duplicate notifications to our user when we retry the Pinpoint API, right? And fortunately, Amazon Pinpoint API and SDK provides the request ID. So with the same request ID, is always make sure your notification, your campaign won't be delivered multiple times. And another one is, when we import the segments, we keep pulling the status. It may time out, right? And Amazon Pinpoint can automatically detect the stuck importing and restart those things, so we don't need to worry about those things. The last one is about the daily quota control. And I mentioned Amazon Pinpoint provides the basic quota control, right? So you can configure for this app, your users only receive 5 notifications at the maximum. But if you send multi-notification for the same user at exactly the same time, you may run into the risk condition. The user may receive more notifications than your daily quota. We have reported these issues to Pinpoint, and it's on their roadmap to improve it. And at the same time, you may need to consider to implement your quota control on top of this to avoid the risk condition. Monitoring with AWS. So myself think, I personally think moving to cloud, one of the most important benefits, we can leverage all the existing products on cloud. So when the Pinpoint deliver the notifications, it always generate the delivery events, and it publish those events to Kinesis. And we have a Lambda function to listen to this Kinesis event and ingest to the Elasticsearch. And so we can search on Elasticsearch create a dashboard and do analytic. And we also have the Lambda function to ingest these events back to our big data platform, so we can leverage Hulu's big data platform to do further analytics. So this is a very simple event-driven pipeline on cloud, right? So there's a challenge. There's a basic challenge of this is you need to scale each component of this pipeline, and it's very hard to get a high-level view of your whole pipeline. What's the status, and where your data flow to, and how the status of each component, right? And you need to make sure each of your component is configured enough resource, or it can automatically scale. So this is, I think, is a basic challenge on for the event-driven pipeline on cloud. I hope we can see more improvement in this area. Okay, now we schedule the campaign on Pinpoint, and it delivered to our user, and our users see the notification of their favorite game, and they click the notification, right? And for each of the notification, we have a destination, and for web and iOS and Android support the deep link, right? Deep link will take you to a specific content in your app. So ideally, when a user click the live sports notification, they should get into the playback and to watch the game, right? But in reality, the deep link destination varies due to the timing and the variance of our Hulu content. For example, if the live sports game is airing and the user click a notification, we should take them to the playback and start watch the game. And sometimes we mentioned that even we handle the schedule very well, there's a case, we may deliver notification a little bit earlier than the game start. So we can tune into the user, we can tune our user into the channel so they can watch the previous game and they can watch the next game soon. And if the game has ended and we have recorded the live content for our user, we can play the recording content. And otherwise, we may take our user to the detail page of the game we just shown there. And this is there are tons of other scenarios we need to handle. So Hulu built its own deep link service to make sure no matter when our user clicks a notification, no matter how the live sports schedule change, we can deliver the best user experience to our user. So this service responsibility is to choose the best channel, choose the best content for our user. Okay, that's all I'm going to talk about our notification solution, and then I will talk about some learnings and our future plan. Yeah, I mentioned the most two important properties of notification is timing and relevance. So live TV program schedule accuracy is very challenging, and even our Hulu team try best to unify this. We still could encounter issues. The schedule information is inaccurate, and we need to make sure we can deliver the best experience no matter how the schedule is to achieve the best experience. The second is about the audience building accuracy and efficiency is a key thing for our system. So the accuracy is about the relevance, right? We need to deliver the notification to the right audience, and the efficiency is, we need to make sure we can build the audience in time and deliver the notifications in time. Buy and build. This is basic, right? With leveraging the cloud products like Amazon Pinpoint, Amazon S3, the candidates Elasticsearch, we can gain the benefits of stability, scalability, and we can make our team productive. We can focus on our own business. And also, we also learn some system limitation. I mentioned the silent notification, right? With the silent notification, you have full control in your mobile app. You can do further processing in your when the notification got delivered, and you can do further schedule this kind of thing. And you can have very good tracking of the delivery and the impression. But it has a lower delivery rate, especially on iOS. With the non-silent notification, it has a much better delivery rate, but you don't have chance to process your notification in your mobile app. It is very challenging to track the impression, especially on iOS. Our future plan. Right now we have the live game start notification, right? And the next step we're considering to introduce the in-game excitement notification. Basically, when there is some exciting moment happened in the game, for example, there is some perfect goal or this kind of thing, we want our user to be notified and they can engage the exciting moment. The second feature on our roadmap is a notification center. So right now we support our iOS and Android mobile clients. We'd like to expand our notification experience to the web and the living room. Even though both web client has good push notification support, and we considering a unified notification center will give our user more values. So we are planning to develop the notification inbox so our user can track all the notifications they received before they can tune into the games from there. The last one is in-app notification. Basically, when our user browsing, when they are browsing with the Hulu app, they are finding content. If there are some games they're interested in, are airing, we can pop up a message to our user. Oh, okay, there are some interesting games. You can click it and tune into the channel to play the notification immediately. Okay, that's all I'm going to talk about our notification platform. And thanks everyone for being here. And we will be here for a few minutes. If you have any questions or if you want to discuss anything with us, just come to here. Thank you, everyone.